So first thing first, guys, I have amazing news. Today we're starting chapter 18, and you might not realize how amazing that is. Chapter 18 is where everything starts to get easier in this quarter. So I can promise you that you have made it through the hardest material. From here on out, everything is going to be significantly easier than what you've already done. It's going to feel like a piece of cake. Congratulations. I hope that the last few chapters didn't fry your brains too much. We are moving into biochemistry, which is just a whole lot easier than organic chemistry. So chapter 18, this chapter is sort of our kind of a crossover chapter in between organic and biochemistry. And this is, I'm like trying to flip through my notes. I believe this is the last chapter. Yeah, this is the last chapter that has any organic chemistry in it at all. And in this chapter, we're talking about amines and amides. And so what we're going to do initially is just a refresher on the amine and the amide functional groups. They both are nitrogen-containing functional groups, so they're similar in that regard. And the nitrogens have 3 bonds and 1 lone pair. The amide has its nitrogen attached to a carbon-oxygen double bond, and the amine does not. In the amine, the nitrogen is attached to 3 things. I'm abbreviating them as R. The R can either be a hydrogen or it can be a carbon chain, but it cannot be a carbon-oxygen double bond. The amide has 2 of these R's on it, and the carbon-oxygen double bond also has something on it as well. And same thing, that R can either be a hydrogen or it could be a carbon chain. And we'll look at quite a few examples of amines and amides both. For amines, they can be further classified as primary, secondary, or tertiary. Primary, we abbreviate one with a little degree symbol. So a primary amine would be one that is a nitrogen that has only one of its R's as a carbon chain. So maybe I'll write like CH2, CH3. This is an example of a primary amine. So it has on the nitrogen 2 hydrogens that are directly attached. So that's referring to these 2 guys right here. 2 hydrogens directly attached. And it has 1 carbon chain. And the carbon chain, like I said, could be as big or as little as what we wanted it to be. A secondary amine, which we would abbreviate 2 with the degree symbol, amine. We don't say second degree, we say secondary. A secondary amine has only 1 hydrogen on the nitrogen, and it has 2 carbon chains. So I'm just going to make like two different carbon chains. Maybe the carbon chains are the same, maybe they're different, maybe they're big, maybe they're little, it doesn't matter. So on the secondary amine, on the nitrogen, we have 1 hydrogen, plural, 1 hydrogen that is directly attached. And we have 2 carbon chains on that nitrogen. And then the third type of amine is the tertiary abbreviated 3 with a degree symbol, tertiary amine. And you might be able to predict what this one's going to look like. This is going to be a nitrogen that has no hydrogens directly attached. And it's going to have 3 carbon chains. And maybe they'll all be the same. Maybe 2 will be the same and 1 will be different. I've drawn one where all 3 of them are different. So for our tertiary amine on the nitrogen, we have 0 hydrogens that are directly attached to the nitrogen. And we have 3 carbon chains. So let's go to the worksheet and practice identifying amines and amides and primary, secondary, tertiary. So one of the reasons why I personally like chapter 18 is because a lot of the pharmaceuticals, most pharmaceuticals are amines or amides. So the molecules that we study in this chapter are very interesting to me. And here we have a list of molecules or a bunch of molecules that contain amines and amides. And what we're going to do is go through and classify these as primary, secondary, or tertiaries. Before we do that, let's make a note what each one of these means. A primary has 2 hydrogens, 1 carbon chain. A secondary has 1 hydrogen and 2 carbon chains. The tertiary has 0 hydrogens, 3 carbon chains. And the amide, which we're going to run into some amides here, although the worksheet didn't tell us to look for amides, we're going to run into some of them. That is the amide, a nitrogen next to a carbon-oxygen double bond. So first thing we're going to look at is lidocaine, the local anesthetic. There's 2 nitrogens in lidocaine. This one right here, because it's adjacent to the carbon-oxygen double bond, this is an amide. This is not an amine, and we won't classify it as primary, secondary, tertiary. This guy right here is an amine, and it has 1, 2, 3 carbon chains attached, so that means that it is tertiary. See, that's not that bad. So let's go down. The next structure underneath this, we have Valium. Valium also has 2 nitrogens in it, and this first one, because it's adjacent to carbon-oxygen double bond, this one is an amide. This nitrogen is special. This is an amine, but it is, if you can see, it has a double bond on it. And so when we have a nitrogen that has a double bond, or even if it were to have a triple bond, we count each one of those bonds as like its own carbon chain. So this has 1 carbon chain right here, and this double bond counts as 2 carbon chains. 1 for each bond, which makes that nitrogen a tertiary amine. So that's kind of tricky, but that's how we do it. We could also, if you were counting how many hydrogens were on that nitrogen, there are no hydrogens on that nitrogen at all, so that would be another way that you could classify it. Remember, in line structures, when we're looking at line structures, nitrogens only like to have 3 bonds. Nitrogen has only 3 bonds. So if you're looking at a nitrogen and you can see 3 bonds, 1, 2, 3, you're seeing all 3 of its bonds. There are no hidden hydrogens. So let's go over up to the top again. Let's go to Xanax, because this one has a lot of nitrogens in it. So let's start with this one right here, because that one's relatively easy. So we can see this nitrogen has 1, 2, 3 carbon chains, so that means it's tertiary. That one's pretty easy. So this next one, this bond is really short, but it is a bond right there. So this nitrogen has 1 carbon chain, 2 carbon chains, 3 carbon chains, so it's also tertiary. This nitrogen, same thing, it has 1, 2, 3 carbon chains, so it's tertiary. And this last nitrogen, 1, 2, 3 carbon chains, it is also tertiary. Lots of tertiary amines. Let's skip cocaine for a second. We'll come back to cocaine. Let's look at morphine. Morphine has only one nitrogen in it right here. I just got zoomed out. Morphine right here. And morphine has 1, 2, 3. So that's a tertiary amine. Look at the crazy structure of morphine. It's a really beautiful molecule. Novocaine, we have 2 nitrogens in novocaine. There is a carbon-oxygen double bond in novocaine, but it's too far away from either one of the nitrogens to be an amide, so it's not an amide. The carbon-oxygen double bond has to be right next to the nitrogen. So we don't have to worry about that. This nitrogen, this is the first one we'll start with, it has 1 carbon chain, so that's a primary amine. And our other nitrogen has 1, 2, 3 carbon chains, so it's a tertiary amine. And then last but not least, let's look at cocaine. So there is one thing about the cocaine structure, that the way that we draw it in line notation, that kind of confuses students, that I want to show you. Do you see right here, this is where I'm circling, that's where we're looking right now. So do you see these gaps right here in the structure? That is trying to tell you, this is a way of drawing, trying to tell you that there is a carbon-carbon bond right here, and there's another carbon-carbon bond over the top of it. So it's like 2 bonds that are sitting one on top of the other. So when you look at the cocaine line structure, this right here is not a carbon atom. It is, instead, it is 1 bond on top of another. So that has nothing to do with amines, but something that people, when they look at that structure, like if you were being asked to count how many carbon atoms were in that molecule, which let's do that after we classify the amine. But if you were being asked to count carbons, that would be something that would be confusing to people. So for the nitrogen, let's classify it. It has 1, 2, 3 carbon chains, so it is tertiary. And then, like I said, let's count up those nitrogens, or count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's a lot of carbons.